Let's take a look at our calculator. Here we are. We've got a mean. See the normal curve here, just like in your book? And I've put where z is equal to 0 is right here where the value 135 sits, because when I put 135 in this box here, when I put that in there, it replaced 0, the z-score, because there's no relative standing up or down from 135, with 135, and then I put a standard deviation of 11.5 in. So you fill in these two values, and you go, okay, what's the likelihood of getting a value above 158? Remember, 158 was our value that was 2z equal to, or z equal to 2. So because it divided into 158 minus 135, divided into a z-score of 2, so this is one standard deviation, two standard deviations away, and the likelihood of getting a value above that is 0.0227, which is 2.27%. So it's unusual value to get it out there. That's a low likelihood. How about a value below 112? The value below 112 is 0.0227. Remember, the z-score, the relative standing, was a z-score equal to 2, both for 158 and for 112. So it would seem reasonable, because this is a uniform kind of curve, a mirror image from one side to the other, that the likelihood of getting a value less than 112 would be equal to the likelihood of getting a value greater than 158. So the likelihood of getting values that are unusual to this distribution, this mean of 135 with a standard deviation of 11.5, the likelihood of getting a value less than 112, greater than 158, let's put those two values in, between 158 and 112. Likelihood of that happening is 0.9545. Now we're erring a little bit here on the cautious side by using the value of two standard deviations. To be really, to get a clean 95%, we would use the value of 1.96. So we're getting a little bit greater than 95% likelihood of getting values between 158 and 112. But it's 0.9545, which is 95.45%. So it's easier conceptually for us to work with plus or minus two standard deviations. It's, for all intents and purposes, it's 95% likelihood to, when you're plus two standard deviations or minus two. So just remember that that z-score tells us a relative standing to the average, and it's tied to a likelihood of certain points occurring or not occurring. And we won't consider ourselves to be in the unusual area with data until it exceeds 158 or less than 112 on this set of data. The 6 points that we have that has an average of 135 and a standard deviation of 11.5. If we had a totally different set of data, like the age of our Oscar-winning actresses in there and the standard deviation, we would have the same curve, plus or minus two standard deviations, but we'd be using a new mean and a new standard deviation. The probability curve works for any data set of this type, and it will tell us where we can start to expect usual and unusual data to occur. So take care. That's a fair amount to digest, but it's a critical point or set of points in our study of statistics, and really continues to play out in the rest of the work that you're going to do in the coming weeks. So enjoy the statistics, and remember to kind of sit back and relax with it. The frustration always occurs just before insight, so be patient with yourself in your study of statistics and some of these new concepts. And stay in touch with me. Email me or give me a call at 585-455-1243. 585-455-1243. Take care now.